Welcome to solverfy.
So we need to show that x equals sine of omega t plus the phase constant is a solution of, and then this would be m times d, the second derivative of x with respect to time, plus the damping constant times the first derivative of x with respect to time, and then plus the spring constant times x, and this is equaling f naught cosine of omega t, because again, we know that there is a sinusoidal external force. And so at this point, we can find the derivative. So dx over dt is going to give us omega a naught times cosine of omega t plus the phase constant phi. And then the second derivative would simply be equal to the derivative of the first derivative with respect to time once again. So this would be negative omega squared times a naught sine of omega t plus phi, the phase constant. And so at this point, we can just substitute. So we can say that m times negative omega squared you simply have to substitute these first derivatives into this equation here that we're trying to prove we're trying to prove that the solution for x, rather the function of x is a solution of that equation here. And so this will be plus the damping constant times omega a times cosine of omega t plus phi. And then this will be plus k times a sine of omega t plus the phase constant. And this is equaling f naught of cosine omega t. So at this point, we can then group and say that k a naught minus m. We're essentially just using algebraic manipulation in order to make the equation a bit simpler. We're also expanding the trigonomic identities, because by expanding the trigonomic identities, we can group these functions with respect to time. Cosine of omega t cosine of phi naught, or the phase shift, and then excuse me, this will be minus sine of omega t sine of phi. And again, this equals f naught cosine of omega t. After this, then we have to group by function of time. So then we can say k a naught minus m omega squared a naught times cosine of phi minus the damping constant times omega times a naught sine of phi naught sine of omega t, plus, and now this will be plus k a naught minus m squared a naught times sine of phi minus b omega a naught cosine of phi naught times here it would be cosine of omega t, and this is equaling again f sub 0 cosine of omega t. And we know that the equation has to be valid for all of we know that the equation has to be valid for all times, which means that the coefficients of the functions of time must be the same on both sides of the equation. Since there is no sine omega t term on the right side of the equation, so this would be considered the right side of the equation. This means that the coefficient of sine omega t must be 0. So here, this coefficient here, of course, must be 0 because there isn't any term on the other side. So relating this would be a bit easy because then we can simply say that Ka prime Ka minus m omega squared a naught times cosine of phi minus the damping constant times omega times a times sine of phi, this equals 0. And so we can say that tangent of phi is going to equal Ka minus m squared omega a, or m omega squared a, divided by b omega a naught. These cancel out. And so this is going to equal K minus m omega squared over b omega. This is going to equal m omega squared minus m omega squared. And this will be divided by b times omega. So we can say that tangent of phi is going to equal omega squared, omega naught squared minus omega squared, divided by omega times the damping constant divided by the mass. And so we can say that phi will equal arctan of omega naught squared minus omega squared divided by omega times the damping constant divided by the mass. And we know that this is exactly equal to equation 1424. So the solution can be seen in this triangle. We have our phi here, and here would be WB over M. Here it would be omega squared minus omega naught squared minus omega squared, and then here would be the square root of omega squared minus omega squared, and this would be squared, and then this would be plus omega squared b squared over m squared. So that triangle would demonstrate the solution, and now we have to equate the coefficient of cosine omega t. So from here, we say that this entire term here equals the force. So let's get a new workbook and say that Ka naught minus m omega squared a naught times sine of phi naught plus b omega a naught cosine of phi naught, and this equals the force. So at this point we can say a naught, this will be times k minus m omega squared, and then this will be times omega squared minus omega. Let's just draw this a bit smaller because this is about to be a little bit large. And then here it would be the square root of omega naught squared minus omega squared, and then this would be to the second power, and then this would be plus omega squared b squared divided by m squared. And then we would have plus b omega squared, and then times again, close parentheses equaling f naught. And inside here would have omega b over m. And then for the denominator, it'll be again the square root of omega naught squared minus omega squared plus omega squared b squared over m squared. And so at that point, we can then factor out an m and say that a naught times m would be equal to omega naught squared minus omega squared quantity squared divided by omega naught squared minus omega squared plus omega squared b squared divided by m squared. And this will be plus omega squared b squared divided by m squared. And then this will be divided by the square root of, again, omega naught squared minus omega squared plus omega squared b squared over m squared. And this equals f sub 0. And so we finally divide by m, and we have that a naught equals m times the square root of omega naught squared minus omega squared plus omega squared b squared over m squared. And then for the numerator, the force. And this is exactly equation 1423. So that's how we would prove it through direct substitution. That is the end of the solution. Thank you for watching.